Number 5. Australis Mons, Mars. Australis Mons is 11.3 miles high. As such, it is one of the tallest mountains in the solar system. Australis Mons is the tallest of the 3 volcanoes on the Thargus region on Mars, the other 2 being Pavas Mons and Arsia Mons. All 3 of them are classified as the shield volcanoes, which means that instead of aggressively emitting molten lava, they are shaped by lava gradually flowing down their sides, thereby forming a shield-like shape. Ascarius Mons, Pavanus Mons, and Arsi Mons comprise the Tharsis Montes. Ascarius Mons was first discovered in 1971 by a spacecraft called Mariner 9. Though it was initially thought to be a large spot in a dust storm, which was then called the North Spot. However, later images in the following years revealed that the North Spot was actually a giant volcano and was then appropriately renamed. Number 4. Busali Montes, Jupiter's moon Io. Io, the 4th largest moon of Jupiter, is without a doubt one of the most geologically active objects in the solar system. Io was discovered in 1610 and was named after one of Zeus's lovers. Every few minutes, a volcano erupts on Io. This further implies that the surface is very young and is always replenishing. Because of this activity, it also contains 150 mountains, and the tallest one is Busali Montes. Located just to the northwest of the Pele Plume deposit, Busali Montes is 17.5 kilometers or 10.8 miles tall, which is 2 times the height of Mount Everest. Busali Montes got its name from a cave in Egypt where, according to Greek mythology, Io gave birth to Zeus's son, Epiphus. What's interesting about Busali Montes is that it's the largest non-volcanic mountain in our solar system. It's also worth mentioning that Io is also home to a few other over 10-kilometer tall mountains, such as Ioan Mons, East Ridge, and Euboea Montes. Before we move on, make sure to subscribe to our channel with notifications on. Number 3. Equatorial Ridge, Saturn's moon, Iapetus. By far the most prominent feature of Iapetus, one of Saturn's icy moons named after Titan Iapetus from Greek mythology, is its 12-mile-high and 1,300-kilometer-long equatorial range, one of the tallest in the solar system. The interesting thing about this ridge is that it's running almost perfectly across 2/3 of the moon, giving its unique walnut shape. Although this ridge was discovered on December 31, 2004 by the Cassini spacecraft, its origin still remains unknown. One thing that is particularly difficult to explain is the fact that this ridge follows Iapetus' equator perfectly. There are, however, several schools of thought regarding this strange phenomenon. One theory is first brought up by the group of scientists that were part of the 2004 Cassini mission, is actually a remnant of Iapetus' earlier oblate shape when the moon was spinning faster than today. Others think that this is a remainder of a collapsed ring. There are also some scientists who believe that equatorial range on Iapetus is a result of an icy material being pushed up from beneath the moon's surface. Number 2. Rhea Silva Mons, Asteroid Vesta. Rhea Silva Mons isn't actually located on any of the planets in the solar system or their moons. Instead, Rhea Silva is located on the asteroid Vesta, the 2nd largest asteroid in the solar system. It is 314 miles in diameter, with a peak that rises 14 miles, or 22 kilometers, from its base. As such, it's one of the solar system's tallest mountains. The interesting thing about this mountain, other than it being incredibly tall, is the fact that its diameter is actually 90% of the diameter of the asteroid itself. Rhea Silva Mons is believed by scientists to be one of the solar system's largest impact craters, meaning that it has been formed as a result of planetary scale impact, the same impact that scientists believe created the Vesta family of asteroids. In case you are wondering, impact crater is a depression that can be found on the moon's surface, or on the surface of any other body in the solar system for that matter. They are formed as a result of an impact with a smaller body at incredibly high speeds. In 1997, this impact crater was discovered by one of the largest and most versatile telescopes, the Hubble Space Telescope. But it wasn't until 2011, when the Dawn spacecraft arrived, that this crater was named. Rhea Silva Mons got its name from Rhea Silva, the mother of Rome's founders, Romulus and Remus. Number 1. Olympus Mons, Mars. In the year 1971, NASA sent the Mariner 9 spacecraft to orbit around the planet Mars, and upon arrival, they were welcomed with a global dust storm, which hindered their ability to take pictures of the surface. However, as scientists patiently waited for the dust to settle, they quickly realized that there was a mountain that was peeking out above the dust clouds. And later, they quickly realized that this wasn't actually a mountain at all, but rather the tallest volcano in the entire solar system. This volcano was given the name Olympus Mons, which is really fitting because Olympus comes from the term ancient Greek mythology referring to the home of the 12 Olympian gods. Olympus Mons is located in the Tharsis Montes region close to the Martian equator. It is 550 kilometers or 342 miles wide, which is approximately the size of the country of France or the state of Arizona. It's roughly 25 kilometers tall, 3 times taller than Mount Everest on Earth, whose peak is only 8.8 kilometers above sea level. Olympus Mons is so tall that it even towers above the clouds of the Martian atmosphere, and that's something no mountain on Earth could even accomplish. While Olympus Mons is technically a volcano, it is one that does not erupt. It's classified as a shield volcano, meaning that instead of spewing lava and volcanic material high into the air, it lets lava constantly flow down its sides. As a result, the volcano has a low entrance, with an average slope of only 5%. Eruptions can last hundreds of years at a time. It has 6 misshapen craters, also known as calderas, piling on top of each other to form a depression at the peak that is about 85 kilometers in width. These calderas appear over time when magma chambers were emptied out of lava and collapsed, unable to support the ground above it. A varied depression surrounds the bottom of the volcano as its enormous mass presses into Mars's crust. As for now, Olympus Mons got so big, NASA explains that's because of longer lava flows, which is likely due to a combination of lower surface gravity as well as high eruption rates. As a result, more lava piles up, and the volcano grows taller. Movement of tectonic plates also plays a large part in this difference. Olympus Mons earns a top spot on our list of